Next up, we have Peter Reid, CEO of PTR Minerals, talking about the Muckanippie Titanium project, a significant critical mineral discovery.
Good morning, ladies and gentlemen. It's a pleasure to be here, and it's also a pleasure to finally make it to session 2 after lots of times in that first session there. Today I'm going to talk to you about the Muckanippie project, which is located in northern Gawler of South Australia. We'll just move forward here. In our compliance statement there, you'll see that we've got also references to all the various data that I'll be reporting over the next 15 minutes. So if you're interested in any of this, what we're talking about, you can find them in those references. This is a shot of the Rosewood prospect area. It's the southern slopes of Rosewood where, well, in July last year, our geologists found some very interesting outcrops, a Cretaceous sand, sitting there with little black peppery minerals, and it turned out to be full of titanium mineral. And last year we reported, those early results, and I'm pleased to say 12 months on, things to continue to go in a very positive fashion. I'll just move on to the next slide, and these sort of investment highlights I think we can bring out as we talk through the presentation. Just quickly, we're well financed. We've got just over $7 million in the bank. We actually went into a trading halt today, raising further funds, and those funds will be used to finance this project all the way through to complete PFS stage. So we're very confident of what we found, and we're now taking it to the next level. We've had a nice rise in the market. Our market cap's about 90 mil now, so we've been doing okay. We've been solid, and we've been building our team. We've brought on a project development manager and engineer to look at that work, Victor Raggio, who's here in the audience today. And we've also built expertise corporately with the addition of Rob Sennett, an executive director. He's a banker. He knows about money. He also ran MDL, which was a large mineral sands project in Senegal, which was ultimately sold to the Swiss government, sorry, the French government. Now, Petrotherm historically are copper gold explorers. We've got two good copper gold plays on the Gawler Crater in South Australia, the Maple Creek project, and the Northern Reaches, the Olympic Domain, and our Wimmera project just west of Oak Dam. There, we've got on those tenements, we've advanced them to the point of actually having some drill-ready targets, some really lovely gravity features there, which are, I think, tier 1 targets in their own right. So if there are any mid-tiers or large cap companies out there that want to finance a JV, come and see me afterwards. But our focus over the last 12 months has really been on the Muckanippie project, which occurs in the northern Gawler Crater of South Australia. We got there via our Comet project, which you can see there too, just to the northeast. Comet, we went back and explored for Archean gold. There was an old low gold system there we're quite interested in. And we're also, I guess, old enough to realise that calcarite sampling didn't really work in the northern Gawler, so we went back there and tried what we call saprolite sampling. So we had an auger rig going down about 10-15 metres through the transporter cover and sampled the top of the saprolite. You often get a nice geochemical plume at the top of that saprolite, and we used that as a targeting tool to find gold, and indeed it found located new prospect areas, but it also identified a lot of rare earths, and 3 years ago rare earths were all the rage, as you know. It's coming back a second time now. And we found some really good resources of rare earths hosted in clay, but you can't pull those rare earths out. They're mostly secondary monazite type minerals, but maybe we can float them. We're looking at options to develop that. But one of the peculiar things about those rare earth occurrences were they associated with these late mafic laid intrusions, which also had PGEs and gold and other interesting things. And we thought they were probably Muckanippie sweet age, so we started to look at Muckanippie a bit closer. That, of course, is a large laid intrusion, and we started to build a ground position there. And as we learnt more about the Muckanippie sweet, we realised too it had a great titanium vanadium potential. This is a close-up of that Muckanippie project area showing our tenement holdings there and our drilling to date. And that blue outline is an interpretation of the basic outline of the layered Muckanippie sweet intrusion. It's a ultramafic to mafic to felsic intrusion, thick and northsite sequences. So we have these layered intrusions around the world. They often have lots of metal in them. The most well-known one, of course, is the Bushveld. But other layered intrusions like this include the deposit that hosts Lacteo, Rio Tinto's titanium mine, Telness in Norway, another layered and northocite intrusion, also hosts a large titanium bedrock deposit. When we got to that area, there had been a little bit of drilling in a place called Widgety, and you can see there broad intercept, hundreds of metres at 6 or 7% titanium dioxide and about 25% iron. So that's interesting, potentially commercial. But the drilling prior to the work we did was always on the most intensely magnetic features. And as you know, ilmenite is weakly magnetic. We started looking at the more weakly magnetic features, and there was one drill hole drilled by another explorer up at Claypan, which intersected titanium in the bedrock there up and included grades up to 20%. And once you get above about 15% titanium dioxide grades, you are actually looking at something that's commercial. So our interest was to go and look, see if we can find horizons within that layer complex which might have titanium grades in excess of 20% that may be commercial. What happened was when our geologists went out in the field is they found these younger inland sea sediments preserved. These are probably Cretaceous age Algebachna sands. So we had a very fortuitous geological setting. We've got this large layered intrusion that would have been exposed in recent geological past. We actually had a bit of the edge of the Eromanga Basin shoreline forming on the northern edge of that. And all those titanium minerals had been washed out of the bedrock and concentrated in those titanium sands. And that's what our geos picked up on the ground. So that's been a major discovery, I think, and I'll show the results of that shortly. But I would also just want to highlight that we've been drilling into this layered intrusion at various horizons, such as the Duke prospect and the Nardu prospect, where we have intersected very thick saprolitic zones with very high heavy mineral concentrations, about 40% heavy minerals, and of those heavy minerals, about 60% of that is altered ilmenite or ilmenite, and includes some leucoxene. So those weathered saprolite zones have potentially economic concentrations of mineralisation too. We can see that here. This is a cross-section from one of those prospects at Duke. We've got a zone that probably extends over 16 kilometres. It's about 200 metres wide, 50 metres thick, where we've got ilmenite and altered ilmenite concentrations in excess of 10, 20, up to 30% concentration in that saprolitic zone. So that has some potential, I think, for future development. But today's talk, I really want to focus on Rosewood. This is the drilling to date. We've conducted 3 rounds of drilling this year, and we're now doing a resource drill phase. It started back in November. And here is an outline of the mineralisation to date. Rosewood East and Rosewood West, you can see there. On the Rosewood East is about 6.5 kilometres north-south, about 2.5 kilometres on average width west-east. And there you'll hit mineralisation in excess of 10 metres at 10% heavy mineral in every hole on average. So it's a very large area of mineralisation. We haven't put out a resource as yet, but we're doing that. We'll put that out in Q2 next year. Rosewood West has been drilled on a very coarse level, but it also looks like we have a high-grade zone there. Rosewood East is probably a north-south strand line. We have another strand line we actually see to the northeast, we call Echo Prospect. Rosewood West is probably more of a back lagoon type facies. But you can see some of the drill intercepts there and some exceptional intercepts there, say 26 metres at 17% HM, 28 metres at 13.6% HM. One of the interesting features of this HM is it's all valuable HM. 95% of that HM is valuable titanium minerals. We don't have really any monazite. We have very little zircon present. And that's because the source rock, the later northocite, has a different chemistry. An example, cross-section through Rosewood. Mineralisation typically starts at about 5 metres, typically 10 to 15 metres thick. We have these deeper channel facies too. You can see there in Rosewood South there, where we're getting intersections up to close to 30 metres and well over 10%. One of the really nice features of this discovery is that we've got a lot of high grade ore. In fact, we've had intercept up to 50% HM, and I'm getting reports back from the geos now. They're doing the infill. They reckon they can beat that this next round of drilling. So it's looking really exciting out there in terms of grade and tonnage potential. One of the unique features about Rosewood is its particle size distribution. Now, in mineral sands, you want a coarse ore, so you can separate it using wet separation technologies. We have a very coarse ore. The P50 is about 300 microns. Normally, a coarse strand line ore might be, say, 120, 150 microns. So we're almost double. But the other feature is we actually have ore of every grain size you want. We've got 1 micron ore, we've got 4 centimetre grade ore, and everything in between. So what we've reported on, when we say we've got 10-15% type head grades, that's the bandwidth between 38 microns to 2 millimetres. There's actually a lot of ore above 2 millimetres, there's a lot of ore below 38 microns. So we're looking at ways now maybe of capturing that 20 to 38 micron fraction. We're looking at ways to, when we process that ore, to do attritioning to break it down and get more of that higher, coarser ore as well. So I think we're already in a great position with exceptional grades, but I think we can improve that with further processing work. Now, we've conducted 3 large-scale bulk sample tests this year, 1 with IHC Royal, 2 with Mineral Technologies. This is some of our ore coming down the IHC spiral. So here we use, spirals and a bit of a helter-skelter to concentrate your heavy minerals. You can see the heavy minerals forming there on the inside that are taken off. This was a 1-tonne bulk sample from Rosewood. We've had, the other 2 have been 100 kilo samples. And as we speak, we're blading now a big interval of northern Rosewood where we're going to do a 3-tonne bulk sample test. The head grade is, exceptional, between 10, 12, 15% head grade. And as mentioned, we might actually be able to improve that as we can learn to recover more of the HM out of the sand. And with the test we've done to date, we've had pretty good recoveries, between 86 and 95%. So I think with the learnings, being a different ore, having a huge grain size variation, having odd grain shapes too, we've been able to find ways very quickly to process ore very cheaply. And we can produce a concentrate that's exceptional quality. You're aiming for like a 90% heavy mineral concentrate. We can get 95, 98% heavy mineral concentrate just with a rougher spiral and a few magnets. So it's very easy to produce a really nice concentrate. This is some of our first ore. You can see there on the left. We've produced, I think, about 130 kilos of product already, which I think is a fantastic achievement. It has very low deleterious minerals. It's principally what we call a leucoxene. So that's a titanium mineral averaging between, say, 70% to 90% TiO2. We have some rutile, about 5 to 10% rutile. We have some altered ilmenite. When I say altered ilmenite, it's an upgraded ilmenite that has a concentration, say, between 55 and 65% TiO2. So we've got a nice high-value product. It's clean, it's pure, a very simple process to extract, and it's very low in deleterious minerals. There's no uranium, thorium, low manganese, low aluminium, a little bit of silica, but I think with a bit more cleanup, we'll get rid of that pretty easily. So I think we've got a really exciting product, and the guys have achieved a lot in just in 12 months. This is sort of really where our product mix sits. And when you look at global titanium markets now, it's very interesting because most of it comes from low-grade sulfate ilmenite, ilmenite ores which are 30 to 50% CO2. There's a lot of CO2 to fire that to produce a titanium slag. We can actually produce a premium product that's like a titanium slag level just by digging out of the ground and washing it and producing a concentrate. So I think it's going to be placed into the market. There'll be buyers out there that really would like this product because of its green principles. And of course, as you know, most of the titanium goes into the pigment industry. The paint manufacturers, I think, can see that Rosewood ore here has great potential. In terms of how do we actually get it to market, we're in a remote area, we're on pastoral lease land, Commonwealth Hill area. One landowner, we've got one native title group, we have excellent relationships with both parties. Also the Woomera Defence Area, we're on the southern edges of that, we have great relationships with Woomera people. But we're only 35 kilometres away from the Adelaide to Darwin railway line, so with our scoping work, we're looking at setting up a haulage road, which would take the ore then by train down, most likely down to Whyalla, which is essentially a stranded asset as we speak. There's land there, there's a port there, there's capacity for extra use of that port and the rail, and that's the most likely spot that our concentrate would go to. And we're looking at ways of maybe evaluating that ore by setting up a mineral separation plant at Whyalla, where we can produce a high-level rutile, a high tie product, say a leucoxene level product, and an altered ilmenite product, and go to various consumers going forward. But just finally, what are we doing now? The resource drilling started early November. We hope to have that complete by Christmas time. Otherwise, the guys miss out on their Christmas lunch, but I'm sure they'll get there. And we're doing a lot more bulk sample test work. We're doing additional product separation testing. We're refining the process flow sheet of how we produce this concentrate. We've just completed our initial flora and fauna studies on the ground, where the mining lease application may go. We're doing water studies, initial pit design work, plant design work, all that's underway. So the aim is to have our initial resource out Q2 next year, and I'm quite confident it's going to be big and high grade. And then in the second half next year, we'll have that scoping study complete, and we're well funded, as mentioned right at the beginning there, to take that scoping to a pre-feas going forward. So that's us in a nutshell. Thank you very much.